Hello everyone, welcome to Physics Pathfinder. Today we are going to cover the topic A3, which is work power energy part 1. Under this concept, under the under the concept of work power energy, we are going to concentrate on the basics of work and power, efficiency, and solve various exam style questions. So before we proceed further, let me remind you to like and subscribe my channel and press the bell icon to get the latest updates. So let's start with the concept of work. When is work said to be done? Work is said to be done when there is a force and that force is able to displace the object in the direction of force. So the formula for work done is F into S cos theta. Now you have to understand that when a work is done, for example, if there is a force applied in this direction diagonally, and because of this force, the object is moving or displacing in this direction by S. Theta is the angle made by F with respect to S. Now, the quantity that we are supposed to take is the force should be in the direction of displacement. So you have to take the component of force which is in the direction of displacement. So we have to see the horizontal component of F, which is F cos theta. And hence work done is defined as F into S cos theta, where theta is the angle between the two vectors F and S, and force has to be in every case in the direction of displacement. Let's apply it into this exam style question. So look into this example. There is a barrel that is having a weight of 2.5 into 10 to the power 3 newtons. It is moving along the slope, going above. Okay, it is going above in this direction. So the displacement is in the direction of the force, which is moving upwards. Theta is 40 degree. And the question is, what is the work done? So let's, if you remember, the weight is vertically downward. So you have to resolve it into two components. If you can see here, there is a component of F, which is perpendicular to the slope, and there is a component of F which is parallel to the slope. We are going to see the component of force which is in the direction of displacement. So we are going to use this mg sine theta in the direction of displacement. So always take the force in the direction of displacement. So this is F into sine theta, and this S is the displacement along that direction. And that is given that it is 6 meters. So your sum is basically F dot S sine theta. Plug in the values and look for the answer. So if you see here, it's 2.5 into 10 to the power 3 times 6 meters into sine of 40. That should give you the answer, which is 9.6 into 10 to the power 3, which is the option D. You can see here. This is the answer. So always understand the component of force in the direction of displacement is what you're supposed to take. Let's go for another example. An 80 kg person is going to pull a block which is of 15 kg. The angle made by the rope is 40 degree with the horizontal. The person is pulling with the force of 40 Newton, and this moves the box by 20 meters horizontally from the starting position at a constant force of friction. There is another force which is 5 Newton. So if we can see the marking in the diagram, mass of this block is 15 kg. Mass of this block is 15 kg. The angle made by the rope is 40 degree given. There is displacement in this direction, which is 20 meters. 40 Newton force is applied here. And force of friction is always in the direction opposite to motion. And that is 5 Newton. So step 1, when you find multiple forces, you resolve it to get one answer. So step 1, we look for a force which is in the direction of displacement. So basically it is 40 cos 40. This is the force in the direction of displacement, so in this direction. The reverse forces to be subtracted so that you get one answer. So your first step will be 40 cos 40 minus 5 Newton, which you subtract 5 from that, the answer that you get is 25.6 Newton. If that is the resultant force, then work done is F into S. That's it. So just multiply 25.6 with the displacement of 20 meters. The answer is 512 joules. Next, let's see the concept of kinetic energy. Any moving object that has a mass m and moving with a velocity v, kinetic energy is given as half mv squared. Now let's see its units. Kinetic energy is mostly represented as joules, but its SI unit would be SI unit, which is in fundamental units, would be unit of mass times unit of velocity square. So it is kg meter square per second square. Now you can also use the concept of momentum. So by the concept of momentum, if kinetic energy is half mv square, there is square of v, but if I square the m, multiply by m at the top, I have to compensate by dividing m at the bottom. And you know that m into v is momentum. So can I tell that kinetic energy in terms of momentum is also equal to p square over 2m? Look at this example. A body traveling with a speed of 12 meters per second. So there is a velocity given to you. Kinetic energy is given, which is 1650 joules. If the speed of the body is increased from 12 to 45 meters per second, estimate the new kinetic energy. So very clearly we know that kinetic energy is directly proportional. If mass is a constant, it's directly proportional to v squared. So can I make two equations for the situation that 1680 is proportional to 12 square? Then if velocity is 45, what is the kinetic energy? We can do it by ratio method. 1680 times 45 square over 12 square should give you the answer for x, which is the energy. And that should be 23,000 joules. The answer is 23,000 joules. You can have a look here. Next is the concept of potential energy. So if I have a mass that is raised through a height of delta h, then any object which is at a height of h has a potential energy which is equal to, again, work done or energy stored is nothing but force time displacement. Okay, so whatever work is done on this ball to raise it through a height delta h, it is stored as the Gravitational potential energy. So energy stored is F into S for an object. The force acting on an object is its weight, which is M times G, and the displacement is by a distance of delta H. So work done is nothing but the change in potential energy, which is mg delta H. Look at an example for the same. To get to his apartment, man has to climb a flight of 5 stairs. Each stair has a height of 3.7 meters. So you can find out the total height, which is 3.7 into 5. The man has a mass of 74 kg. Calculate the gain in GPE. So which is nothing but mg delta H. Mg we know is 74 is his mass. G is 10. Delta H is nothing but 3.7, the height of one stair times the number of stairs, which is 5. So the answer that you get is A, which is 13,000 joules. Next is the concept of spring. So when you attach a mass to a spring, you can see here, if I have a spring and I attach a mass at the end of the spring, there is an extension because of this mass by a distance S. If it extends by a distance S, then there is a restoring force, so if you try to remove this mass, what will happen? In this stretched position, if I remove this mass, the spring is going to jump backwards because of a force in the direction opposite to displacement. So more the extension, more is the restoring force. But you can very well see both the vectors are in the opposite direction. So what can I tell? I can tell that the restoring force is directly proportional to the extension, but in the opposite direction, and hence a minus sign. Since it's attached to spring, we have a constant, which is spring constant. So we can tell that restoring force is equal to minus K times extension. So look at an example here. You have a graph of force versus displacement. Step 1 is to find a spring constant. So you can very well see from the formula that spring constant is force over extension. So dividing the two quantities is basically finding the gradient. So select 2 points in this graph, which is now subtract change in y, y2 minus y1 over change in x, which is x2 minus x1, should give you the answer for slope. So change in y coordinates will be 15 minus of minus 15, because the negative y-axis is minus 15, so it's 30 over change in x. Change in x means the coordinate in x-axis is minus 30 minus of 30. So this in x-axis, it is in millimeter, so multiply it into power of 10 to the power minus 3 to convert it into meter. 10 to the power minus 3. So your answer should be 30 over 60, which is half, and half times 10 to the power minus 3, which comes upwards to become 10 to the power 3. So the answer is 500 Newton per meter. So we have completed the first part. The second part is looking for a force if the displacement is minus 65 millimeter. So use the equation F is equal to minus Ks. You have K, which is 500 Newton, and displacement, which is minus 65 into 10 to the power minus 3, converted into meter. So the answer for force is around 32.5 Newton. The next is the concept of work done. How can I find work done if the extension is along the positive 0 to 40 millimeter? So very clearly 0 to 40 millimeter is negative for this graph. So I redraw the graph and make a positive slope. So to find work done, you know the formula for work done is force times displacement. So for a graph, force times displacement is nothing but area under the graph. So if I redraw the graph and find the area under the graph, I find the area under the shaded region from 0 to 40. Okay, this here is the 40th. So area under the graph is half base into height, which is half of 20 times 40 into 10 to the power minus 3, should be around 0.4 joules. So next is the concept of how can I prove that elastic potential energy? So when you compress a spring or you extend a spring, the energy that is stored is the elastic potential energy. And that's what you're supposed to prove, that when you do a work on a spring by compressing it, then the energy stored is half K times extension square. So let's see how do we prove it. You know, by the concept of work done. Work done is nothing but area under the graph, which is half times force times extension. Now, we already know that by Hooke's law, the force is nothing but K times extension, which is the substitution for force, and extension written again as it is. So you can very clearly see when you compress a spring, the work done is stored as the elastic potential energy, which is given as half times K into extension square. And this is called as the elastic potential energy. Look at an example here. There is a car which has a shock absorber. One of the spring with the shock absorber has a K spring constant is given to you. And the compressed distance is 10 centimeter. So your extension or reverse extension is 10 centimeter. Calculate the energy stored. So take care of the units. So you know that the elastic potential energy stored is given as half times constant times extension square. So just plug in the values, half times 50 kilonewton. So have to have the power of 10 to the power 3. And extension is 10 into 10 to the power minus 2. That should give the answer around 250 joules. What is conservation of mechanical energy? As you can see, mechanical energy is the sum of total kinetic energy and total potential energy. If it is a spring, then it will also have the elastic potential energy. So whenever you have multiple energies, if you add all those energies for that system, then the total energy is called as the total mechanical energy. And conservation of energies actually implies that if the external force acting on that system is 0, then mechanical energy is going to be the same before and after the event. So very clearly, conservation means before an event, whatever it is, the same is going to be after. So if I'm dropping an object through an height of delta h, the energy initially was gravitational potential energy, and as it falls down, it gets converted to kinetic energy. So in sums involving conservation of energy, we use the concept loss in potential energy is equal to gain in kinetic energy. It could also be a spring that is stretched. Once you release it, the entire elastic potential energy gets converted to kinetic energy. Let's see an example here. A person is skiing down the slope, okay, through a distance of 750 meters and making an angle of 25 degrees with respect to horizontal. The skier starts from rest, and 15% of the initial GPE is not transferred to kinetic. So out of 100%, 15 is not transferred, means 15 is lost. What is left is 85%. So can I tell that 85% of the gravitational potential energy is getting converted to kinetic energy? They want the final speed of the skier. So very clearly I can cancel M because that is not required. It's there on both the sides. So G is 10, height is 750, 85% is 0.85 times GH. Get the 2 on the other side and take a square root, you get the answer for velocity, which should come to 73 meters per second. Next is the concept of power. Power is defined as the rate at which work is done. So rate means anything divided by time. Rate at which energy is transferred, rate at which work is done, both are same. So the unit is joules per second, which is also called as a watt. Look at this question. A car engine exerts a following force of 500 Newton along a distance of 1 kilometer in 200 seconds. What is the average power? So we can know that power is work done upon time. Work done is F into S cos theta if theta is involved, or you can just put in the values divided by time. So you have force, which is 500 Newton. Displacement is 1000 meters over 200 seconds. So you should get around 2500, which is correct, 2500 watts. Now we have to prove, we already know that power is force times displacement. Power is rate at which work is done. You are required to prove that power is also F into V cos theta. So we'll start with what we know. Power is work done per unit time. So can I write work done as F into S cos theta over T? And very clearly, S over T is displacement over time, which is velocity. So we can prove that power is F dot V cos theta, which is the required thing. Look at an example. A lorry that moves up a road on an inclined plane is 14.5 degrees with respect to horizontal. So you know theta here. You know the speed with which the lorry is going, 9.4 meters per second. You have the weight, which is 3500 Newton. Calculate the useful power from the engine to move the lorry up the road. So we are going to use the concept of power as force into velocity. Now force should be in the direction of the displacement or change in velocity, change in distance with respect to time, which is velocity. So we are going to take the part of beat which is parallel to the slope, which will be mg sine theta times v. So your answer should be 3500 times 10 times sine 14.5 into velocity of 9.4. That should give you the answer. Efficiency is defined as the ratio of useful work to the input or useful power to the input power of a machine. And efficiency is either a decimal lesser than 1, or if you time your answer with 100, to get it in percentage, it is always less than 100%. So look at this question. An electric motor has an efficiency of 35%. It lifts a load of 7.2 kg through a height of 5 meters in 3 seconds. Calculate the power of the motor. So you are given efficiency. You are given the useful work, which is the output work, which is nothing but the energy stored when you're lifting an object through a height of delta H, which is 5 meters. So here the work done is nothing but the gravitational potential energy, which is mgh. So we can calculate power is mgh over t, substitute the values, which is 7.2 times 10 times 5 over 3. So it is 34 times 5, which should give you the answer of input power as 353.16. So this is the input, this is the output power. Output power over the input power is efficiency. So input power is nothing but output power over efficiency. So we got the answer for the output power. Divide that with the percentage uncertainty, the percentage of efficiency, that is going to give you the input. Let's look at the last question for the day. The diagram shows a pump in a hydraulic dam. In one such pump, you have water that is stored, which is 700 kg. The speed given is 3.5 Newton, and the kinetic energy of the water to lift the small quantity of water through a height of 12 meters. Efficiency is 20%. Which mass of water could be lifted 12 meters? Find the mass of water that is lifted through 12 meters. The energy at the top is mgh. It's getting converted to kinetic energy, and 20% of the kinetic energy is what is the output. Cannot cancel the m's because the m's are different. So the left side will be 700 into 10 into 12. The right side will be, so it is 700 into 10 into 12 is equal to 0.2 times 0.5 into m, we don't know, into v square is 3.5 square. So on solving, you get the answer for M, which is around 7.3 kg. So that's all for today. Do watch the second part of work power energy very soon.